Hi students, welcome back. We are going to learn third lesson in math magic, that is how many squares. This is the most interesting game we all have played. So, who makes the squares? By joining the dots, completing a square, one can write his name or his initial. So the person who gets maximum number of squares is the winner, right? There's no hard and fast rule about the rows and columns, number of rows and number of columns of these dots. You can mark them a page full or half page, so whatever you feel like. Okay, coming back to the mathematics, suppose we have made these dots, and can you tell how many blocks of squares are within these dots, or you can make out of these dots? How do you do that? You can count individually, but you can use multiplication table as well to get that number. Now, how many rows are there? 1, 2, 3, 4, 5, 6. 6 rows are there, right? And the columns. The rows we have 6, and let us count columns. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I got 15 columns. Okay, you got the clue? Can you please tell how many squares can be drawn with these dots? It's a simple equation. Rows multiplied by columns is 6 multiplied by 15 equals 90. So there are 90 blocks. 90 square blocks are within these dots. Right? Now the task is, this red square is there, and we need to draw as many rectangles as possible using 12 such squares. It's a simple equation. One rectangle equals to 12 squares, right? And we have 90 squares in this. So how many rectangles we can make? 90 divided by 12. 7 blocks of 12 plus 6 squares will be left. We can make how many rectangles? Each containing 12 such squares. We can make 7 rectangles out of these dots, right? It's a simple thing. You can check it other way. You see, we have counted rows 6. So one row will have 6 blocks, and another row you will have another 6. 6 plus 6, 12. So 2 rows you will have 12 squares. Like this we have how many columns? 15. So 15 is not even number. Let us leave 1. So it will be 14. 14 columns. 14 columns divided by 2 is 7. So we can make 7 rectangles of 12 squares each, right? A rectangle needs 12 squares. Can you tell the multiples of 12? It can be 2 by 6, 2 rows with 6 columns, 6 columns with 2 rows, or 3 rows and 4 columns. In whatever way you want to do, you can do. The value of the multiplication should be 12, right? We have 6 blocks here, and you can take 4 in this way, and you can make a rectangle here, another rectangle here. That way also, if you make it, you can make how many rectangles? It's a 7, right? Now, do you know what is perimeter? You take a triangle. If this is side 1, side 2, side 3. The length of the side 1 plus side 2 plus side 3 is equals to the perimeter. If each side has 10 centimeters, then the perimeter is going to be 10 plus 10 plus 10, that is 30 centimeters. Okay? This is your house and this is your compound wall. Can you tell the perimeter of your compound? This is the boundary of your home. Suppose you want to put a wire or the fencing around your home along this outer surface or outer border of your home. Then you need to calculate the perimeter of this boundary or the boundary wall. Then you can calculate the length of the wire required or anything else, right? Suppose this side is 10 meters and this side is 15 meters. So the opposite sides are equal. So this is 15 means this is also going to be 15 and this is 10 means this is also going to be 10. So can you tell what is the perimeter of this boundary? That is going to be the length of all the sides. We have two 15s, 2 multiplied by 15s plus 2 multiplied by 10. So can you tell what is the sum? 50. 50 meter is the perimeter of your boundary wall. So in the previous one, suppose each square is 1 centimeter by 1 centimeter. So what will be the perimeter of this? A square has 4 sides. Small block is 1 centimeter square. So considering each side is 1 centimeter in length. So can you tell what is the perimeter of the small square? A square has 4 sides and each side is 1 centimeter. So it's going to be 1 multiplied by 4 equals 4 centimeters. Right? We made rectangles with 2 by 6 blocks equals to 12 square centimeters. Can we know what is the perimeter of this? We made rectangles with a combination of 2 by 6 and 3 by 4, right, equals 12. And there is another combination also, 1 by 12. Why not? We can make it. So let us calculate the perimeter of each shape. So if it's a 2 by 6, the perimeter is going to be, so opposite sides will be 2 centimeters. So 2 times of 2 plus 2 times of 6. Right? There are 2 sides, each of 6 centimeters. So it will be 2 into 6. Okay, the total is going to be 4 plus 12. That is going to be 16 square centimeter. Right? Okay, coming to this one, 3 by 4. So we have 2 sides of 3 centimeters and 2 sides of 4 centimeters each. Now the perimeter is going to be, now for the rectangle with 3 by 4 combination with 3 blocks by 4 blocks, area totaling 12 square centimeters, the perimeter is going to be 2 times of 3 plus 2 times of 4. This is how much? 2 3s are 6, 2 4s are 8, 6 plus 8, 14 square centimeters. If it's a 3 by 4 or 4 by 3, the result is going to be the same. Okay, we have another combination. Take a block and put 12 blocks in a line, in a row. That also will make a rectangle with 12 squares, right? The perimeter is going to be 2 times of 1 plus 2 times of 12. So let us total this. 2 plus 2 12s are 24. 24 plus 2 is 26 centimeters. Sorry, earlier I put as a square centimeter. No, that is centimeter. The perimeter is the length. Length is in centimeter, and this is area. This is square centimeter. This is square centimeters. That is the area. And this is perimeter. Right? Now, can you tell? Now, can you tell in what pattern, if you arrange the blocks, you are going to have the maximum perimeter? So, obviously, the last one, put 12 blocks in a row. That is going to have 26 centimeters of perimeter. So, that's the longest. And the smallest perimeter is going to be 3 by 4 blocks. 3 blocks by 4 blocks, and that is 14 centimeter. Right? So area is always length by breadth, and the perimeter is sum of all the sides. You got the concept? Area is length multiplied by width or breadth, we can call, and perimeter is sum of all sides. So in your home, on the floor, check for the tiles. You will have tiles and count how many tiles are there. Usually each tile will be of 1 square foot. You will watch some symmetry of the tiles. You will have some tiles. You count them. Mostly the tiles are going to be 1 foot by 1 foot or 2 foot by 2 foot. So 1 foot by 1 foot means it's a 1 square feet, and 2 by 2 means it's a 4 square feet. So if you count the number of tiles, then you can know the area of your floor, of particular room or particular or entire house. Suppose in a room you have 100 tiles, and each tile is 1 square feet, means it's a square room, so it has 10 tiles in length by 10 tiles in width. So 10 multiplied by 10 is 100 square feet. So this is the area, means carpet area. If you want to lay down a carpet, so you need this area, right? And along the border, you want to organize something, some lighting or so, then you will need the perimeter. So for this room, the perimeter is going to be sum of all the sides. It has how many sides? 4 sides. Each side is of length 10 feet. So the perimeter is going to be 40 feet. Right? Foot and feet. Foot is a singular if it's a single foot, and feet is plural. Foot and feet, there will be some confusion. So area we count as a foot, square foot, and this length is feet. So remember this, foot is singular and feet is plural. Now you have some books, notebooks with square blocks, right? That is easy to make some drawings or to do any projects. Here we have some stamps affixed to this grid book. So each grid is of 1 square inch or 1 square inch. This is a small one, small book. Okay, now Let us do some practice. So, any one of you collect stamps? That is a hobby. You can collect the stamps of various countries. And the hobby is called philately. Philately is collection of stamps. This is Indian stamp. Stamp is used for the postage, for postal purposes, that is fixed or applied to the postal documents as transport charges paid by the sender or sometimes by the receiver as well. We have some questions here. Let us see this question. How many squares of 1 centimeter side does stamp A cover? This is stamp A, B, C, D, E, like that. Okay. So, each block is of 1 centimeter in length by 1 centimeter in width. So, the area of each square is 1 centimeter square. So, this formula is important. Area is length into width is centimeter multiplied by centimeter is square centimeter, that is area, and perimeter is centimeter only, as you are summing all the lengths. Whereas here you are multiplying the length and breadth, so you have a square over there. Right? In our case, each square is of 1 centimeter by 1 centimeter. The stamp A, how many blocks it takes? So you can count one by one or use the tables. Using multiplication table is easier. So you see how many rows and columns. Area is simply calculated by multiplying rows by columns. Length by width. Okay, in our case, stamp A has 1, 2, 3. These are the rows, 3 rows by columns. How many? 1, 2, 3, 4, 5, 6. 6. So now you got the answer. Stamp A is 6 by 3 is 18 square centimeter. Right? Stamp B, how many rows are there? 1, 2, 3, 4 by columns 1, 2, 2 columns. So the area of B is 8 square centimeters, means it's occupying 8 blocks. 8 square centimeter blocks. Next question. Which stamp has the biggest area? So, for that we need to calculate the area of all the stamps here. So, let us count C. C is having 2 rows by 3 columns. 2 by 3, that is 6. So, area is square centimeter, no need to write here. D, 1, 2, 3, 3 rows and 1, 2, 3, 4, 4 columns. So, D is going to be 3 by 4. So, that is 12 square centimeters. And E is 2 rows and 2 columns. 2 by 2 is 4. F, 1, 2, 3, 4, 4 rows and 3 columns is 12. Now we know the answer for this question. Which stamp has the biggest area? A has 18, and that is the biggest area of all. Right? Answer is A. And how many squares of side 1 centimeter does this stamp cover? That means how many blocks? It is simply 18 blocks. Each block is of 1 centimeter square. Next question. How much is the area of the biggest stamp? Is 18 square centimeter. Next question. Which two stamps have the same area? Look at these answers. D has 12 and F has 12. So these two have the same area, 12 square centimeter. And the next question, how much is the area of each of these stamps? It's 12 square centimeters. Next question, area of the smallest stamp is how much, and which one is that? E. E is the smallest stamp, and its area is 4 square centimeter. Yeah, by looking at this blocks also you can see simply that E is the smallest and A is the biggest, right? And you look at D and F, both have the same area. Here it is 3 rows by 4 columns, 3 by 4, that is 12, and F is 4 rows and 3 columns, 4 by 3. So the pattern is different, but the area is same, right? And this is a tricky question. The difference between the area of the smallest and the biggest stamp is dash. Smallest is 4 and biggest is 18. So 18 minus 4 is 14. 14 square centimeters. We love to do the stamp collection. Collect some old stamps. Now we are using private mailing parties and not using stamps. But if you get a chance, collect the old stamps. And for the preservation, use the square grid paper for the proper organization. So this is some practice. Guess which has the bigger area, one of your footprints or the page of this book. You can obviously say the page of this book is bigger than your footprints, little footprints, right? Which has the smaller area, 2 5 rupee notes together or a 100 rupee note. When it comes to the area, 2 5 rupee notes will have more area than the 100 rupee note. So here the answer is going to be 100 rupee note. But its worth is more than 2 5 rupee notes. Next question. Look at a 10 rupee note. Is its area more than 100 square centimeter? 100 square centimeter means it's 10 centimeter in length, 10 centimeter in breadth, and definitely it's not going to be more than 100 square centimeter. Use a scale to measure the length and breadth of the 10 rupee note and find out what is its area. This is another tricky question again. We have a square and we have a rectangle, and the question is the area of the blue shape more than the area of the yellow shape? You see the left side is square and is cut by this diagonal into two pieces, two triangles. These two triangles are equal. And at the right side you have a triangle cut by this line into two triangles. Suppose if you pick this triangle and place it here, this is going to be square or bigger. I guess it is a rectangle, not a square. So if it's a rectangle, the height of these two objects seems to be same, but the length, if you see the length at the bottom, is more for the blue. In this case, blue color shaped object, this triangle is having more area than this yellow square, right? Is the perimeter of yellow shape more than the perimeter of the blue shape? Okay, so let us say each side is of 1 centimeter. So the perimeter of this square is going to be 4 by 1, that is 4 centimeter, right? And this blue triangle, just now we calculated that it is a rectangle and not a square. And the sides, the bottom side is longer than the bottom side of the square. So in that case, the sum of all the sides are going to be more than 4 centimeter. So the answer is blue shaped triangle is having more perimeter, and the reason for why is, and it's having a and more length but the same height as that of square. Okay, how big is my hand? You can trace your hand on this paper, yours, and ask your friend also to do the tracing of his hand, so you'll find out which one is bigger. So that by the appearance you can tell, and also by counting the number of squares. So count the area of your hand in terms of the number of squares and your friends. It's easy to tell whose hand is having more area or bigger. Similarly, you can stamp your feet and make footprints, you and your friends, and you can measure them by visual as well as by doing some tracing. You can find out whose footprint is bigger or smaller, right? And here the question how you will decide. So you had to do some tracing, measuring to find out which one is bigger or smaller. You know the footprint an ant makes, a bird makes, and of course the rhino and the elephant. So you know which one is bigger, which one is negligible or hardly seen, right, or smaller. Here is the another calculation for the grids. So this is the footprint of a hen, and you know how do you calculate? If any grid is occupying around 50% or more than 50%, you count it as one square. And if it's negligible, like this one, you see on this here, this is maybe 5% or 10%, that square you ignore. You are doing some rounding off here, and that way it helps you to calculate the area. So let us start from here. Footprint is extending to the top block as well. You ignore as it's a very small area, and below that is also less than half of this square, that also you ignore. And the bottom, this is also hardly 10% or 20%, this also ignore. Column 1, column 2, you count them as a 0. And coming to the column 3, here you have this feet, and it is occupying more than 50%, so count this as 1. And the next square, it is also more than 50%, count as another 1. And coming to the bottom, that's negligible, count as 0 and 0. And go to the next column. Here in the second row, it is less than half, 50%, so ignore it. And below that, it's equal to, it's more than 50%, so count it as 1. And below that is negligible, less than 50%, so the rest of the things also can be ignored. So now the area is going to be 3 square centimeter. That is how you calculate the footprints, the area of the footprints. These are not regular footprints, irregular. So if it's of proper square, then it's easy to calculate the area of it. Now below is the footprint of this dog. So based on the way we calculated, you can calculate the area of this dog's footprint. So I'll give some hints and clues. So on the first row, this block, this square can be ignored as it's less than 50%, and below also can be ignored, but the below one is nearly 50%, so you count as a 1, like that. Okay, let's move to the next. Make big squares and rectangles like this to find the area faster. This is a footprint of a tiger. Pug marks, tiger marks, footprints are called pug marks. And now, with the rounding off, you can count the number of squares. Right here you see the example is given. So these are the full squares, the proper squares. And the remaining you need to do some rounding off to calculate the area. That is going to be around 95 to 99% approximation. You do this practice at home. You calculate yourself and match it with your friend's calculation results. And you can use some multiplication tables instead of counting all the blocks. So you can mark and multiply the rows by columns to arrive at the major area in each pattern. Okay? How many squares in me? How do you calculate the area of U? You lay down somewhere and you make some tracing. So that is by following the grid policy, by using the grids. So can you tell what is the area of this triangle? This is a rectangle, right? Rectangle, area of a rectangle is length by breadth. So this is length, this is breadth or width. So this seems to be, length seems to be 2, width seems to be 1. As visually you can see 2 square blocks here. So this is 2 by 1. So the area is going to be 2 square centimeters. And you see this diagonal across joining the opposite corners. This will cut the rectangle into 2 halves, equal halves. In that case, the area of the triangle is going to be half of the area of the triangle. Half of 2 is 1. So the area of the rectangle is 1 square centimeter. Here also you see this pattern, this line is dividing this rectangle in symmetric way. So definitely the answer to this question, is the shape half of the rectangle? Yes. And this boy wants, what's the area of this shape? So it's simply half of this rectangle. Rectangle is having 2 rows and 4 columns. 2 by 4 is 8 square centimeters, and half of that is 4 square centimeter. Right? That's the answer to this. Now, can we find out the area of the shapes below? Yes, we can. Based on the estimation, approximation calculation, can you do this? This is your homework. Any questions? Let me know. I'll help you. Small clue I will give you. You see, this curve is dividing this square and this square. Whereas if you see this yellow portion in this square, if you fit it here in this block, it will fill it. So this is going to be 1 square. So like this, you can approximate, you can calculate and count the area. Try triangles. So in this picture we have 2 triangles with the same bottom. The bottom size is fixed and the top crossing intersection point is moved. For one triangle it is here on the left corner and another one is here. So by the rule, the area of these 2 triangles, blue and the red, will be the same. You can try counting and check the result. That is, by the principle, these 2 triangles will have the same area. The shape and appearance are different, but the area is going to be the same. You can play a lot with a grid book. Okay, try forming different shapes other than rectangles, pentagons, squares, and hexagon, and try calculating the area and compare it with other shapes. So this shape is different from the previous one, which is something asymmetric, and this is symmetric. And try counting the area of the both. Try comparing. This grid is 1, 2, 3, 4, 5 by 5. That's a 25 squares. And here also, this is drawn in 25 squares. And do the comparison, and you will be able to answer these simple questions. A question appears to be simple when you know the answer, when you know the logic to calculate, right? When you don't know anything, then that's a wonder, that's a surprise, that's a confusion, right? Practice, practice to feel, to give you the confidence. Some practice here. So draw some pictures, some lines and shapes, and try counting the area. So this one you see this is a rectangle with 20 square centimeter. Yes, 2 rows and 10 columns. 2 by 10 is 20 square meters. And what's the question? Draw one straight line in this triangle to divide it into two equal triangles. And what's the area of each triangle? So you draw a line from this corner to the other corner. This way or the other way, from this corner to this corner. It will cut this entire rectangle into two triangles. And each will have the same area. Each triangle will have the same area. And each triangle will have 10 square centimeter area. So two triangles make 10 plus 10, 20 square centimeter. This is a simple practice and try doing it. You will enjoy it. We have 5 squares. Measure the side of a small square on the squared paper on the page. So here we have 5 squares. And what are the maximum number of shapes you can make? Some shapes are drawn here. You recognize these shapes. There is these blocks you will see in some game. You got that game? You remember that? You must have played this already. Check with your friends if you don't know. So try all the different possible shapes you can draw. And count the perimeter and see which shape has the longest perimeter and how much. And similarly shortest perimeter and how much. And the area of what is the area of the shapes? That is going to be the same, that will remain the same, as all the shapes are comprising only 5 blocks, each 1 square centimeter. So whatever be the shape, the area is going to be the same, that is 5 square centimeter. So these are all the possible shapes using 5 squares. You recognize the shapes and practice. So here you got the answer and all the shapes in this. You recognize them and check with your answers. This is another puzzle. Not simple, but try it. So you all know this. What this grid, black and white grid, and where it is used. Of course it is chess. And you count the number of grids. This is some game to play with the shapes we created earlier, and you will understand this better, and it's simple, right? So these are all the different tiles and shapes. It may be in your kitchen or in your bathroom tiles, bathroom walls, or some other pantry areas. You can count the number of tiles and the area they occupy. And you can make your own patterns also, own blocks also, with the different colors, and to make them look like really beautiful tile structure. So this looks beautiful, and these are all appearing to be 1 square foot tiles, or maybe 1 square centimeter tiles. Making a tile using a pattern is more important and more interesting. In this tile, you can answer these questions. It's a simple. These are all the different shapes, patterns, and you can form tiles out of this. And you can use them to form different pattern outcomes. Okay, you may look at your curtains or the blankets or what you wear. You may find some interesting patterns, and quickly you can tell how many blocks are there and what is that pattern. Thank you, children. We'll meet again in another session.